Formation of Earth's atmosphere. Like solid Earth, the atmosphere formed because of differentiation. During the original differentiation of Earth, less dense gas molecules, such as hydrogen and helium, rose to the surface. Thus, the original atmosphere of Earth consisted primarily of hydrogen and helium. Earth's early atmosphere. The high concentrations of hydrogen and helium did not stay with Earth's atmosphere. Earth's gravity is too weak to hold these gases. The sun heated the gases enough so that they escaped Earth's gravity. These gases were probably blown away by the solar wind, which might have been stronger at that time than it is today. Also, Earth's magnetic field, which protects the atmosphere from solar wind, might not have been fully developed. Outgassing. As Earth's surface continued to form, volcanic eruptions were much more frequent than they are today. The volcanic eruptions released large amounts of gases, mainly water vapor, carbon dioxide, nitrogen, methane, sulfur dioxide, and ammonia. This process, known as outgassing, formed a new atmosphere. The gases released during outgassing interacted with radiation from the sun. The solar radiation caused the ammonia and some of the water vapor in the atmosphere to break down. Most of the hydrogen that was released during this breakdown escaped into space. Some of the remaining oxygen formed ozone, a molecule that contains 3 oxygen atoms. The ozone collected in a high atmospheric layer around Earth and shielded Earth's surface from the harmful ultraviolet radiation of the sun. Earth's present atmosphere. Organisms that could survive in Earth's early atmosphere developed. Some of these organisms, such as cyanobacteria and early green plants, used carbon dioxide during photosynthesis. Oxygen, a byproduct of photosynthesis, was released, so the amount of oxygen in the atmosphere slowly increased. About 2 billion years ago, the percentage of oxygen in the atmosphere increased rapidly. Since that time, the chemical composition of the atmosphere has been similar to the present composition of the atmosphere.